Hi everyone, this is Dr. Saida Falafini from Cal Poly Pomona. In this session, we are going to continue our discussion on lean healthcare systems. More specifically, we are going to talk about value stream mapping as an important tool in lean engineering that can help us to improve various systems by removing various sources of waste. Value stream is basically the sequence of all operations or activities that are done. So that we can provide a service to a customer or we can produce a product for the customer. And these steps or these operations can be value added and non-value added. And we just talk about what is the definition of value added operation and non-value added operations. And when we talk about a value stream map is a structured diagram in which we are going to document all these steps that are going to be taken. We are going to specify which one of them are value added, which one of them are not value added. And also, we are going to specify the time associated with each one of them. If you remember in process map, which we talked about in previous session, we said, okay, if we want to document any process, or when we walk into any healthcare setting, or actually I would say any setting, no matter if it's manufacturing or healthcare, if you are in charge of improving a process, the first thing that you want to do is that what is the current state of the process? How is the process is done currently? And the first thing that you would want to ask from the owners or your customer is that, do you have a process map that can give me some idea as on what are the steps on this process or how this process is being done? And so those are usually the best documentations about the current state of the system. If there is no such a document, I strongly recommend you guys to try to develop that, because once you try to develop a process map, obviously it helps you to understand what is going on. And then later, as a consultant, if you are trying to improve that process, that documentation, that process map can always be your reference that you can use as you're talking to your customer to show that, okay, this is what is happening. However, I see that these are the redundant parts and these are the parts that have to be removed. So that can be your reference to when you want to have any discussion with the customer, you can always go back to that process map. So we talk about process map and how it can help us to document the steps that are happening in a process. And the value stream map is pretty much similar to the process map. However, we specify which one of those operations or activities are value added, which one of them are non-value added. And also in process map, we mainly specify the material flow, the patient flow, but in value stream map, we also identify not only the material flow or patient flow, but also the information flow. Who is sending some information, who is receiving some information, where do they send the information, where they receive the information from. We specify that on a value stream map as well. So as you can see, it's a lot more comprehensive compared to process map. So we specify the value added, non-value added task. We have specified the time associated with each one of those tasks. And we specify not only the material flow / patient flow, but also we identify information flow in that setup as well. And similar to the process map is basically the first visual assessment of what is going on in the healthcare setting or in that company or where any company that you are going to help. And yeah, so it's the first visual assessment of what is going on, and it can help you to see where are the delays and where are the replications and where are the areas for improvement. And usually value stream maps are done by a team and not just individually. And usually if you are hired to work in a consulting company, or if you're a consultant that are going to that has been contracted to work for the consulting company, you have to set up a team of not only systems engineer and industrial engineers who have the analytical techniques, but a team also of people in the problem context, a team of nurses, doctors, technicians who are involved in the process. And then you have to put together this value stream map together as a team. And that way you would be able to observe all the aspects of the process and hopefully develop something that is a lot more complete. So let's look at one example. I actually picked that from, that's coming from the book, and then I also have one that I picked from paper. So this this process map is for the emergency room. And this is what is happening in the process room. So I was just thinking like, yeah, actually this was referenced in the book. Then I went to the reference. This is the reference. This is the paper that I had published the process. It was referenced in the book. Then I went to the reference. I was just thinking about that. I went to the reference, and then I got more information about the process map and so forth. So here we are trying to look at some operations in a emergency treatment or emergency department. So here's the process map associated with the whole process. It's simple. I mean, it's a simple process map. That's what I tried to say. So it's a simple process map. What happens is that patients arrive by ambulance or helicopter. Patients arrive as walking. Okay, either they are come to the emergency department with ambulances, or they come as walking. Then patient is taken to the room. Patient is evaluated. And here it doesn't go through the detail. Obviously, when you go in, you initially check in, then the nurse takes you, then the doctors take you. And so patients is taken to the room, patient is evaluated. And then these are some of the operations that are done in parallel. So the therapy is conducted. So they are looking at what is going on with the patient. Some tests or labs or x-rays or radiology things may need to be performed. The patient is sent to be for those operations to be done as well, and then consult process is conducted. What happens in the emergency room is that when they let you in, after they do the initial assessment, you sit in a waiting room, but then after they call you and you really go in for the treatment and visit, then you go do some labs, you go do some x-rays, but they don't send you out. You still stay in the emergency room. So you don't go back to the waiting room. You still stay in the main treatment part and till your lab results are ready. And since it's emergency room, everything is a lot faster. I remember when I did x-ray for my fractured foot, the x-ray was ready in 10 minutes, but in a usual setup, it usually takes a day or two at least for x-ray to be done. But anyway, so once you go to the emergency room, they do some initial treatment. You may need to do some X-rays or lab. As you're sitting there, these labs and the X-rays are done, and then the whole consulting is done and is completed. And then when the results are in, then the question, when they reach to a conclusion and to a result, then the question is that do you need further treatment or further care or not? If you don't need further treatment, they already told you what you need and they gave you your maybe prescription, then you're good to go. You get discharged. But if you need further treatment, if your situation is a little more intense, then you need to get to the hospital, and that's where the admission process to the hospital happens. And that's where we talk about actually a lot in previous session, that depending on the availability of bed in the hospitals, then we may have boarding situations here, that if there is no bed available in the hospital, patients stays in one of the beds in emergency room, and it may take sometimes about several hours before the patient finally can be treated to the hospital, or even sometimes a day before the patient can be transformed to the hospital. And that's before the patient can be transferred to the hospital. And that's the whole concept of boarding that we talk about extensively in previous session. So what we have here is that from the point that the patient arrives till the point that the patient finally checks in or gets to the room is about 16 minutes. But from the point that finally the patient gets to the room till the point that the patient is either discharged or needs to get to the hospital is about 104 minutes, close to 2 hours. Although this, and currently, I'm sure this is a lot longer number on average for the patients, about 3 hours, I would say. And the whole process till the patient is finally out in a hospital is about 150 minutes. And okay, so that's the process map. And now that would be definitely the first step that we want to do. As I said, in every setup that we walk in, the first step would be, okay, either develop a process map or ask to see if there is a process map, so that you guys get some sense about what is going on in that part or in that department. You could go, I would say, a lot deeper into the process map. To me, this is a very high level process map that has been developed for this emergency room. If I was in charge of this project, I would definitely go a little deeper into the process map, and I would document a little more steps in the process map. And then this represents a summary of the value stream map associated with that process map that we just saw. So this is the value stream map associated with the previous process map that we saw. So what happens is that a patient arrives, okay? A patient that needs care arrives to the emergency. And here, basically, what this means is that the patient goes to the triage, and the vitals of the patients are taken. So this is basically the initial check-in. So, okay, who is the patient, and what is the information associated with the patient? So here, what you see, basically, this 4-minute text tells you that the whole operation here takes 4 minutes, and that's what we see here in CT cycle time. This is the time that it takes to perform this operation. And there is about 2 minutes waiting time before this operation is done, and that waiting time is waste, right? No improvement in the health of the condition happens, or this waiting is not helping with the whole improvement process in the condition of the customer. You may say that, okay, when the customer goes and gives their name, or the customer checks in, no improvement in the health happens as well. Yeah, no improvement in the health of the condition happens, but that's a definitely necessary step. So the rest of the work can be started for the customer. So this is definitely a value-added step that needs to be done, so that the rest of the work also can be done for the customer. And we have about 2 minutes waiting before that, which is waste, but this operation takes about 4 minutes. So before I continue this, I just want to go to the next slide and just tell you, these are some of the most important or most common notes or icons that we use for developing a value stream map. For example, this is the one that shows customer or parts or orders. So if you're developing a value stream map for a manufacturing process, we may show the same icon to show customer orders. I may show the same icon to show a part, a raw material that arrives to the system. Okay, and as you can see here, basically these are the ones in which we show the operations or processes. So that's the one that we use to show the process. Usually, if you see such a sign like this that shows there is a resource that is used to perform this process, and we can also identify the number of resources that we need to perform the process. Usually things like that we also have here in our diagram. You see here we have only 2 rows. Those are what we call as data table. We can have data tables with 2 rows, 3 rows, 4 rows, as many rows as we want. This is your choice. How much information regarding each operation you want to collect. You want to collect how long do they take, how much weight they have, how many people perform there, the level of urgency of the operation. Any information that you want to record for that operation, you can obviously do in this data table. And as you can see, this is usually the way we identify the timeline of an operation. Here we put the time of the operation, and here we put the waiting time before the operation is done. And you can see here that's the case. So here we put the time of the operations, and here in this little step we put the waiting time before this operation is done. And that's exactly this part shows, and the end of the process with the straight line and so forth. So here I put just some of them in the book. I have reference for this course. Actually, there is a long list, but here I put those that I thought they are more applicable and used a lot more. And oops. And here what happens is that, okay, the patient comes, the patient history is taken. Okay, what has happened? This is basically the patient checking. Well, okay, what has happened? When did it happen? Um, and they check in the patient. And then so basically the registration, so that's the registration of the information of the patient into the system. And this is basically showing the information that this is showing the flow of the patient or the flow of the material. If you remember, we said the value stream map shows the flow of the material and flow of the information. And here, this icon shows the flow of information. Once the registration is done, the information of the patient is registered in the database. Okay, so that's happened. And also in our icons, also I have that electronic information, either with this icon or this icon. They are the ones that are used to show the movement or the flow of electronic information. Or the flow of information, electronic or non-electronic. And here is the flow of the material with this black arrow. And after the registration, then the database sends some information to the nurse. RN means registered nurse. The database sends some information to the nurse that a patient has come in with this information, and it will take around 28 minutes before that information is going to be sent to the nurse. And nurse takes about 5 minutes to look at the information and evaluate the information. And then the information is also going to be sent to the doctor, to the medical doctor in the emergency room, that that there is this patient, this is a story of the patient. They take a look, because they are the ones that one of them may definitely make sure, okay, how the priority of this patient has been evaluated, and if they need to do anything specific before, and if they need to rush, or everything that has been recorded with the condition of the patient so far is fine. So so the patient information, the patient's history is provided, and that also takes another 15 minutes between the nurse and the patient for this information to finally be received by the doctor and be reviewed by the doctor. So that's going to be a quick evaluation as well. And then the provider is going to put a request for the lab work and everything, and it will take 10 minutes, or there is some delay or some waiting before the lab work finally is going to be done. And so if the patient needs to go do an X-ray, MRI, or some lab work, that would be quick. The patients do that. And once they do that, their information is going to be collected and is going to also be entered in the database as well. So that's the flow of the information. And then once the lab work is done, then the information of the lab is going to come from the database to the nurse, and then the registered nurse is going to collect the lab information. It usually may take around 20 minutes for the lab work or the X-rays and things to be done, but usually nurse receives those about 10 minutes and analyze those, and then after that, after about 40 minutes, finally the information is sent to the doctor. When they are looking at everything, they do the visit and they talk to the patient about what is going on, and basically they are done with the operation. And when they are done, hopefully it's a patient that has received the care and is going to depart and leave the system, or the patient needs to be transferred to the hospital. And once it happens, then the confirmation about the fact that the patient has been discharged is going to be sent to the dashboard as well. And so obviously here, as you can see, there's a lot more detail in terms of what operations need to be done, how long each one of them is going to take, how long is taking between the previous operation and the next operation. These are all the waits. So these are all the waiting time for the customers that are waste, and they add no value to the customer. And also, as you saw, we said in value stream map, we are going to document not only the flow of the patient or the material, but also the flow of the information. What information is sent from which operation to which other operation, or from which equipment to which other equipment. And then at the end, we can see that, okay, in this whole process, from the point that the customer enters to the point that the customer leaves is about 165 minutes. However, the value added part, when something happened, when there was some value to the customer, either customer was doing some lab work, or the nurse was looking at the information of the customer, or was talking to the customer, or whether doctor was looking at the information of the customer, or doctor was talking with the customer. These are the value added work. And in these 165 minutes, only 46 minutes was the value added work, but the rest was just waiting and the non-value added operations that ultimately we want to be able to reduce and get rid of. So the value stream map is going to help us to document the steps with a lot more detail. It's going to help us to see what are the value added, what are the non-value added, waiting times, waste that exists in the process. And then if there is any redundancy, if there are some operations that have been done and actually it's redundant, is not needed, we can remove them. It also helps us to see those and get rid of those. And also it helps us to see if, even if the flow of the operations is not appropriate, that's something we can discuss as well. And obviously that's something that we can also extract from the process map. If we see that the flow of the information is not correct in the process map, we can also erase the issue using the process map as well. But value stream map also help us to do that as well. But most importantly, the thing that we can get from the value stream map is to see what is the lead time for the whole process, from the point that patient enters till the point that the patient leaves. And of this total time, how many minutes are value added and how many minutes are non-value added time. And obviously our ultimate goal is to use all these lean concepts and operation management concepts to get rid of or to reduce the number of non-value added, or the number of non-value added minutes or time. And this is another example, and I got that from another paper I was looking at. And here they don't have it like as a really full-blown value stream map like what we have here, but obviously you can document this. Like once we get the data associated with these operations and things, we can obviously document this like the way that we showed in previous diagram. But still we can see a lot of helpful things here. This is also related to the emergency department. So first let's look at the top operation. So that's actually the current state of the system. So the ambulance arrive and move patient into emergency department. And then the ambulance hand over the patient to nurse one. Nurse one performs the initial assessment on the patient and then waits for an opening in the majors area. And then once the opening happens, they move the patient to the area. And then nurse, right, when they finally move the patient to the majors area, they are going to hand the patient, the nurse one is going to hand the patient to nurse, hand over the patient to nurse two. So nurse one is going to basically hand over the patient to nurse two. And then nurse two is going to perform another set of assessment. And finally, the patient is going to enter a queue to finally get visited by the doctors in the emergency department and get the actual assessment. And that usually queue is the one that takes the longest. So when we look at this process, obviously the arrival of the ambulance, things like that. So these are all transportation. So that's definitely non-value added. So that's definitely the arrival process. So they bring the patient. Sorry, that's the value added. So that's arrival of the ambulance and making sure the patient arrives to the setting, that's value added. And then the ambulance is going to basically hand over the patient to nurse one, and the time that it takes and all the waiting with that comes with it is what we consider as non-value added operation. Then the nurse is going to perform some of the assessment operations, takes the temperature, takes the pressure, and look at the situation to see how intense the situation is and so forth. So obviously that's an evaluation on the condition of the patient. That's value added. And then the patient has to wait to see if when they can get into the area. And and then when finally there is a room in the area, they move the patient to the area. But these are all waiting and movement. And waitings and movements and motions have no value. They don't have any value for the customer. They don't make the situation of the customer better. Movement part, I would say, is necessary. Anyway, we want to get to the assessment room. So that's a non-value added operation, but it's necessary. But then the waiting part, I would say, is non-value added and unnecessary. I mean, if we have enough space, if we have enough bed, the patient doesn't need to wait, so they can just get to the assessment area. And right when we get to the area, nurse one hand over the patient to nurse two. And again, that's non-value added, like all this time that finally another nurse comes in and takes care. And then the nurse two does another set of assessment. And actually, when I went to the emergency room 2 weeks ago for my fracture, the exact same thing happened to me. Initially, a nurse one, did the blood pressure, temperature stuff. He looks at my food. Okay, there's a lot of inflammation. This looks like urgent. Okay, I got your information. I put your urgency high. Go to the waiting room and wait. And then when they called me and I went to the room, then another nurse repeated everything, temperature, pressure, and everything. And to me, I mentioned that in previous session, and to me that looked like really redundant for someone who has pain in the foot. I'm like, someone just did this a little ago. Why do we need to repeat everything? But that's one example of how redundant operations are. And then after the assessment by nurse two, finally the patient is ready for the main doctor to come and visit. And usually this also is a long waiting process till the final patient, till the doctor is in and they do the assessment. So in this process flow, we can see exactly which one of these operations are value added. Only basically two of them are value added, when the ambulance brings the patient and when the nurse one does the initial assessment. The rest are either waiting, which are non-value added for sure. And then here there is this nurse two assessment that is not, I wouldn't consider it as a waste in terms of the waiting, but it's waste in terms of we are over processing. Remember in the MUDA type of waste, that 6 or 9 type of waste that I showed you, one of them was over processing. So here, why do we need to take all of those pressures and temperature and everything twice? So that's another waste. There is a resource, there is a nurse here who is doing some work that already has been done, and it's also a waste of time because that's the time that we can spend to perform some treatment of the patient. So here, again, we see the value-added operation, we see the non-value added operation, and we can figure out which one of these operations look like redundancy and if the order is good or the order needs to be changed. It would be great if we had some waiting time between these operations. It would be great if I had the time for performing each one of these operations. And if I had those times, I would develop a value stream map in full force, like the previous diagram that I showed you. And also to show exactly when we get the information from the patient, where this information is being recorded, the flow of information, like the previous diagram that I showed you. And here, remember in previous session, I think one of you asked that do we have the same icons for every industry if we want to develop a process map? And my answer was that the icons can change, but it doesn't matter. All that matters is that when you develop that process map or when you develop that value stream map, maybe you put a little dictionary next to your map in which you show what icon is showing what. And here you can see here from the key or this little dictionary on your map, you see that the square light with the light gray shows value adding process. The dark gray non-value adding process. This is the push force, so this is the push of the patient or push of or flow of the material, and then this dotted line shows the flow of the information or the communication, and all of these other icons and so forth. So so even if you use some other icons for your value stream map, that's perfectly fine. Just make sure you have a key or a little dictionary next to your map to show what icon shows what on your map. So, okay, so this is the current state of the system. That's what we always want to know. When we are asked to improve a process, the first step is always, always, always to understand what is going on in the current state of the system. If you don't know what is going on in the system, in the current state of the system, how do you want to improve it? That would be impossible. Always the first thing is to what is going on in the current state of the system. And then after they develop this value stream map, or they observe it, they realize, okay, there is a lot of non-value added tasks. There are some of them that we can get rid of. There are some repetitive tasks that we can get rid of. And after we do all of these improvements, and obviously deciding about which one of them which one of these improvement ideas can be done or which one of them cannot be done. Again, it's not a decision that you can make on your own. You need a team. Value stream mapping, developing the value stream map, evaluating it to find out what are the sources of improvement, and finally coming up with the future state of the system, with your proposal on how I'm going to improve the system. All of them have to be done in a team of not only those systems engineer and analysts, but also a team of nurses and technicians and doctors, and a team of people who know the problem context better than anyone else. And finally, in the modified version, this is what we have. The ambulance arrives and patients is moved to emergency department. And then instead of handing over the patient to a nurse and then to the major area, why not we just take the patient to the majors area, and then hand over the patient to nurse one, and then the nurse does the assessment, blood pressure, temperature, everything, weight, height, everything, and then once the nurse one nurse do the assessment, then the patient goes and wait till they finally call the patient for the final assessment by the doctor. Okay, and as you can see here in both the current state and the future state, here we, on top of the operation, if there is a resource that we use to perform that operation, that is also written. So here we need one nurse, here we need one nurse, here we need a doctor. Okay, so this shows which one of these operations need a resource. So if we are going to get rid of the first or the second, if we are going to get rid of the second assessment by nurse operation, then we know that right here we actually not only shorten the process and smooth we are going to make the process smoother, but also we are going to reduce waste and reduce our resources. We have one less nurse in this operation, and that's what we want to do at the end of the day by value stream mapping. Okay, that would be another example that I got from a paper actually. Is there any question regarding the value stream map? Oh, actually, let me also finish that. So overall, when we are going to use the value stream mapping, we already talked about this, but here I have the documented structured way for process improvement. Investigate and develop the current state, value stream map. Understand what is going on in the current state of the system. When my students come usually to perform the projects, and that happens at the undergraduate level a lot more, they have all the technical knowledge. They just don't know where to start. And that's what I have seen over and over in every project. And my role is usually to help them to come up with a structure, with a framework, with a roadmap for performing the project. And that's the case for my master projects as well. To come up with, if the project is performed in a company, if it's related to process improvement in a company, usually the first step is always to find out what is going on in the current state of what is going on in the system right now. What is the current state of the system? And that's what you always want to do. If you're a consultant or in for any project, even in your own company, that's the first thing that you want to do. Once you find out the current state, what is the current state of the system, you want to analyze it. You want to know what is going wrong, what are the causes for all these underperformance and all these difficulties that we see. Actually, this is a very, very important step, and probably I would say the most important step, because that's where you look at the current map, the current value stream map, and then you say, oh, actually, there's a lot of operations that are redundant. There's some wrong order in the operations. Maybe we can change that. There's a lot of waiting for some of the operations. Maybe we need to hire more resources, more nurses, more doctors for those operations, and so forth. So this step is probably the most important step. It helps you to look at the current state, find the potential causes for the problems that you see, the cause of the problem. And then as you try to design the future state, you are trying to get rid of those causes. You are trying to address those causes of the problem. Okay. If you find that the process is long, or there is a lot of waiting time because there is not many staff, because there is a lot of process that are redundant and they are being repeated for the third time or for the fourth time, that's when in the design of the future state, you get rid of those. So in your future state design, you don't have those operations or those redundancies. And we develop a new value stream map that represents the future state of the system. And this actually is the mode of communication. Once you have a team that helps you to develop the current state of the value stream map, then you develop the future state map by using the team. And that future state map is basically the source of discussions and finally approval by your customer that yes, this is what we want, these improvements are fine, they are doable, that's what we want. And then finally you go ahead, approve, and get the approval and implement the proposed value stream. Okay, so basically this is the structure for any process improvement in using any method, I would say. This is the framework for any process improvement structure. Find out what is going on in the current state. Do the analysis, do the evaluations, do the thinking. Find some of the causes of the issues that you have observed. Next, try to address those causes, try to get rid of them, try to make any change to get rid of those causes. That will give you the future state of your system. And once you get the approval from the customer or your manager, you're good to implement the future state. Okay. Is there any question so far?
Professor, I have a question. When you are designing the current state, are you designing it based on what's happening or based on the methods of what should be happening?
No. Current state is what's happening. Pure what is happening, not what should happen is your future state. What is happening is the current state. Always, always, always. What is going on is the current state, because you want to know what is going on, what are the issues, what are the causes of the issues, and then try to say, okay, how I can get rid of this cause. And that helps you to develop your futures.
I'm just asking because at my work, I know we have the problem that, let's say, the method and the way they're trained, it has a specific set of instructions or steps. but what is actually happening out in the operation may not necessarily reflect that. Some employees are skipping steps.
Okay, then if I was going to analyze those, I actually would document both. I would say, look, this is what we have in our instruction. However, the actual process that is happening is this. And these are the steps that are being skipped. And also I would even analyze the current instruction, the current instruction that you have, that process that is documented but no one performs. I would also take a critical look into that as well. Why people escape this process? If they can do the process, escaping those steps, and everything is still holding and everything is fine, then why those processes are there in the first place? I would actually question those as well. And so I would just document and discuss everything as it is. There's this guideline that has been documented. However, these steps of the guidelines are not being performed. The actual things that happens is like this. So then I would analyze it in terms of, okay, of these steps that are being skipped, which one of them are really critical, which one of them are not. If they are not critical, maybe we have to remove them in the first place. And if some of them are critical, then maybe we have to bring them back and we have to find a way to implement it. Obviously, for a lot of these process improvement, the force of the management is the most important thing for the success of these projects. You can do the best job in analysis of the current state, come up with the best solution, design the best solution, collect all the data in the world to show that this solution is going to work. But if the manager is not behind your work, if there is no force for implementing and sticking to this new states, new design, then it wouldn't go anywhere. So I would say definitely current state is what is being done, and then future state is what you want to be done. Does that help?
Thank you.
Sure. And this is just in parentheses, but and that's because I have seen that in a lot of projects at the undergraduate level and master level. That's actually an observation I have had, and is repeated over and over and over. A lot of the times when the companies come and tell us, we cannot meet customer demand, our cycle time is high, and things like that. The whole current state analysis actually is not a trivial process, because what you are going to analyze, I'm going to look at their process map. I'm going to look at their layout, how the layout is. I'm going to look at their, I don't know, quality control system. All of these things, like just knowing that which part of the current state is the one that can potentially contribute to the problem. All of those are part of the current state analysis. On all of those, I would say, are the ones that depend on them, that are important. And the skill of the analyst, the skill of you guys is the one that can help to see, okay, what are the things that we have to include in the current state analysis. If they tell me that I don't know, a patient takes from the point that the patient arrives to the point that the patient leaves takes a lot of time in a clinic, yeah, I definitely want to look at the process map. I definitely want to look at where are the weightings happening, and which one of the steps are value added, non-value added, and so forth. But maybe one other thing that I want to look at is the layout of the clinic, layout of the hospital. Maybe it's big and there is a lot of movements between these departments. Maybe there are two departments that have a lot of interaction between them. Maybe from the primary care area to the labs, there's a long distance, and patients have to go through this long distance to finally get their lab done and come back again. And however, there is a lot of patients that needs to do that per day. So that would be another thing that I would look at, that all this walking, going to the labs and coming back actually takes time as well. why not we somehow bring the lab closer to the primary care area? If, I don't know, 80% of the patients who come to the primary care doctors end up going to the lab. So if that communication between the lab and primary care doctors happens a lot, why not we bring these two units closer? So that's why I'm saying that if I want to just address the issue related to patients spend a lot of time from the point that the patient enters till the point that the patient leaves is a long time. Maybe I want to look at a couple of things. I want to look at process flow. I want to look at all the value added, non-value added things. I want to look at the layout of the clinic or the hospital and see how far these different parts are from each other and how much of walking and things are. So those are actually all important. I think the experience and the skills of the analyst is the one that helps to look at the problem in hand and find out what are the areas that I think I need to look at to get a sense of the potential causes of the issue that I'm seeing. But these are the ones that, I mean, skills, right? You develop them and you accumulate them with experience. So they will come over time.